This segment, we're going to talk about the time value of money. Would you rather have $1 today or $1 at some point of time in the future? Most of you probably say you'd want it today. Why? Because you can earn some interest. The dollar in the future will be worth, you'll be able to earn something with that dollar, so you would rather have it today. We're going to look in more detail on the value of those dollars. We're going to learn how to use a financial calculator. I'll be using the Texas Instrument BA2+. If you have access to that calculator, it'll be easier for you to work the problems because I'll show you as we go through each problem how I'm calculating it. There are other financial calculators out there. They all should be coming up with the same answer. They work very similar, but if you have the BA2+, you'll be able to follow along with each problem that I show you. Using the calculator, we'll calculate present and future values of lump sums. We'll solve for interest rates and numbers of periods. During this segment, we're going to look at the time value of money. We're going to learn how to use the financial calculator. We'll spend some time calculating present and future values of lump sums. We'll take a look at determining the interest rate you need to receive and the number of periods that it will take to reach a desired amount. You'll realize that $1 received today is worth more than $1 received in the future. Then we'll take a look at calculating present and future values for annuities, as well as determining the payment required to reach that annuity. One of the things you should be familiar with is the rule of 72. The rule of 72 gives an approximate number of periods necessary for an investment to double. So if we take 72 divided by R, where R is the number of percent, will equal the number of periods. For example, if my interest rate is 10%, 72 divided by 10 equals 7.2. That's 7.2 years that it would take to double the amount of money that I'm starting with. Unfortunately, every financial problem does not involve doubling the money. So even though this is a guide that you can use to help you, we'll get into a lot more detail using the financial calculator. Some terminology I want you to be familiar with as we go through the time value of money and using the financial calculator. The number of periods on your financial calculator will be N. N could be a month, it could be a year, or it could be whatever time period you decide to work with. I over Y is the interest rate. The interest rate may also be called a yield or a discount rate. When we're talking about the interest rate, we're talking about the interest rate for the period that we're using. Remember, I just said a period could be a year, it could be a month, it could be a day. Whatever the period is, the interest rate covers that same time frame. So if we're talking annual periods, we're talking an annual interest rate. If we're using monthly periods, we'll have to determine what the monthly interest rate is. We'll talk about present value. On a timeline, the present value will always be the earlier value. We'll talk about a future value. The future value is the later point on a timeline. So if I have a problem that involves dollars today and dollars 10 years from now, if I draw that on a timeline, today is the earlier time frame, would be the present value. The future value will be that later time frame. I may be solving everything in the future. If I'm going to start 10 years from now and finish 20 years from now, the point on the timeline at 10 years would be my present value because that's earlier than the point 20 years from now. The last thing we'll talk about is the amount of the payment. That'll be the amount that is coming in or out in between the present value and the future value timeline. Let's start by talking about future value. The future value is the amount that an investment will grow to over a period of time. Simple interest would provide that same amount of interest each period. But what we're often going to do is we're going to leave our interest in the account to add to the value, which means in the future we'll be earning interest on that interest. That is known as compounding. Let's take a look at a problem here. Future value for one period. What is the future value of $1,000 invested for one period if it earns 8% per period? The future value equals the amount invested plus the interest earned. So here's how you could write that out. The future value, FV, equals investment plus interest earned. The interest earned is the investment times the interest rate. So in this case, I have $1,000. My interest rate is 8%. We'll make that into a decimal. Take 1,000 plus 1,000 times 0.08. The interest earned is $80. My future value is $1,080. Or another way I could calculate that, the investment times 1 plus the interest rate, and I still have my $1,080. Now remember, I don't care if that period was 1 day, 1 month, or 1 year. Whatever that period was, I was earning 8%. So over that period, I will have earned $80, and my future value is $1,080. Let's take a look at the financial calculator. Told you earlier that I would be using a Texas Instruments BA2 Plus. This is what it looks like. A couple things we need to do when we'll set up our calculator. To get started, here's my on-off switch. I turn it on. This gray row right here, you see the N, the I over Y, PV, PMT, and FV. Those are the time value of money keys that we'll be using. There's going to be some times when I tell you to press the second button. The second button is this yellow button. And when we compute, we'll be pressing the compute button in the top left. Bottom left is a clear button. Above some of these rows, you see some printing. Above the N is P over Y. That's our payments per year. We want to set our payments per year to 1. So to do that, if you follow along, we'll press second, and you notice in the top corner of the screen, a second comes up telling you you've pressed it. PY. PY will be the second above the I over Y. PY equals 1. Press enter. Second above this compute button is a quit. I've now set my payments per year. Now let's set the decimal. I'm going to set the decimal for the calculator to 9 places. That way the calculator will not do any rounding for us until we get out to 9 decimals. When we do larger problems, that'll make a difference. If you're doing smaller problems, you may only have 2 or 3 decimals. Just to be safe, we'll set it for 9. So I want you to press your second button. Format, which is above your decimal point. You can see mine is already set at 9. Go ahead and press 9. Decimals equal 9. enter. Second, quit. I now have my decimals set. The top right-hand corner of your screen, there should be nothing. If it says BGN, you will need to look at your owner's manual and switch to end mode. Calculator comes set in the end mode, so we'll leave it the way it is. The BGN will give you some inaccurate results. Back up there. There we have the instructions that I just talked you through. Begin each problem by clearing time value, all your time value of money functions. To do that, second, clear time value of money. I'll show you that one. Second, clear time value of money. That clears the memory on your calculator. Some things to remember with your calculator. Always begin each problem by clearing the financial functions, or that third row. I just showed you how to do that. Second, clear time value of money. Your calculator will remember numbers from previous problems. Without clearing those numbers, again, you'll get some inaccurate answers and you'll wonder what's going on. Key in the value first, then hit the financial function key. For example, if I have an interest rate of 9, I would press 9, then press the I over Y. If I have a period of 1, I would press 1 and then press the N. Percentage values are entered as whole numbers, not as a decimal. For example, 10% would be entered as 1, 0, I over Y. 1/2 of 1% would be entered as 0.5 and then press I over Y to lock that in. You will see some situations where we talk about positive numbers and negative numbers. Anything that is a cash outflow, if it comes out of my pocket, it's a negative thing. If it comes to me, that's a very positive thing. So cash inflows are positive, cash outflows will be entered as a negative number. The answer must be computed. If we're looking for the future value, we'll press compute future value. You can put in the value of 0 for any unused variable at any point in time. That would eliminate the problem of old numbers being left in. At any point in time when we're going through the financial calculator, if the calculator has 4 numbers, it can always solve for the 5th one. And any unused numbers are assumed to be 0. You'll see that here in our first example. We had one period, an interest rate of 8, a present value of 1,000. Where did that 1,000 come from? I had to put it into my investment. Therefore, that was an outflow, a negative thing, so we enter the number as a negative number. A payment would be money we're adding over in between the beginning and the end, or the present and the future. We're not adding anything, so that'll be a 0. And then we'll compute the future value. Let's go ahead and try that. Okay, I'm going to enter the numbers. I have 1, N. My interest rate was 8. 8 is I over Y. My present value is a negative. I put that in So that's going to be a negative because that's a cash outflow for me. On the bottom row, we have a positive negative button. I'm going to make that negative 1,000. That is my present value. My payment is 0. I'm not adding anything in between the present and the future. So just to be safe, we can enter that 0. And then we compute a future value. Hopefully you came up with 1,080. My future value is 1,080. Now, what about investments that are made for more than one period? What is the future value of $1,000 earning 8% if it's left there for 2 periods? We're going to take that future value period by period. So at the end of my first period, I have 1,080. Then we do that again, my 1,080 times 1.08, and I get $1,166.40. Now, if the example I just used, using 2 periods, if it was simple interest, the simple interest would stay $80. We have 1,000 times 0.08 times 2. And we would end up with, instead of $80, we would have $80 each period and have $1,160. Now, let's see how that compares if we compound. By adding that interest to the problem, we can now earn interest on that extra $80. So, if we're going to solve a new problem, what's the first thing we do with our calculator? You got it. Second, clear time value of money. Let's get rid of those old numbers. There's our factors. N is now 2 because we have 2 periods. I over Y is 8. My present value is still 1,000, and we'll compute a future value. So the first thing I do, second, clear time value of money. Everything is cleared. Notice after I hit clear time value of money, it still left a number up there. I press the clear button to get rid of that last number. I now have 2 periods, 2N. My interest rate is still 8%. My present value is still a negative $1,000. I am still not adding any money to it. And when I press compute, would you expect that to be more or less than the 1160 that we showed with doing simple interest? Why didn't it do it? Okay, 2N 8 I over Y All right, Dan, we'll try it once more. I think I got it figured out. I think I know what I'm doing wrong. Okay, we have 2 periods this time. 2N. My interest rate is still 8. My present value, remember it was a negative $1,000 because that is a cash outflow. My payment is 0. And if I compute, would you expect that to be the $1,160 160, or will the compounding add a little bit more money to that? Compute future value. My future value is $1,166.40. $1,166.40. Because we compounded, we gained $6.40. How is the future value related to the discount rate or the interest rate and to time? Remember, the future value of a single sum increases as the number of periods increase. It will also increase as the interest rate increases. It will increase even faster due to compounding. Okay, we've looked at future value. Now let's look at present value. The present value is the current value of the future cash flows discounted at the appropriate discount rate. Discounting being the opposite of the compounding. So we're looking at determining the amount of money before the interest is added to it. Take a look here, the relationship between the present value and the discount rate. What is the present value of $1,000 to be received in 10 years if we have a discount rate of 5% versus a discount rate of 10%? At 5%, we're looking at 10 years, 5%, and $1,000 future value. So what we're trying to determine here is how much do I have to start with? So let's take a look at the calculator again. Second, clear time value of money, and clear that last number off. So I have 10 years, that'd be 10 periods, an interest rate of 5. We'll put our payment in as 0, a future value that will be coming to me of $1,000. So we'll leave that positive because that's a cash inflow. I compute my present value, and I have $613.91. What does that number mean? If I take $613.91 and invest that in an account that will earn 5% per year and leave it there for 10 years, I'll have my $1,000. Now, I said we could compare 10% to 5%. Remember, that's $613. If I double my interest rate to 10%, let's clear our time value of money, clear the last number out. I still have 10 periods. Now I have an interest rate of 10. I have 0 payment, and I have $1,000 as a future value. Compute my present value, and we have $385.54. Notice that's a negative number. That's because that would be a cash outflow. I will take the $385 out of my pocket and put it into the account. So when we compare 5% to 10%, if I raise my interest rate, I can start with less money and still get to the same future value. Think about the present value as the amount that you have to invest at the present time to reach the future value. As you just seen, if you invest at a higher rate, you can invest less today and still get to the same future value. You're indifferent between future value and present value as long as you invest the present value and let it grow to the future value. We don't care that the present value is a lower amount. Now let's take a look at compounding within the year. Because most places where we put our money, we will not have an annual interest rate. It will be compounded. So we'll calculate the future value of $1,000 for 3 years at 6%. And then we'll do 7% compounded monthly. To get it to a monthly APR, we will divide the interest rate by 12. To get the number of periods, we'll take the number of years times 12 to get the number of months. So if I have a 6% annual rate, I divide it by 12 to get the monthly interest rate. I'm looking at 3 years, but I want a monthly period. 3 years times 12 months equals 36 monthly periods in those 3 years. So to solve that on the calculator at 6%, we would now do 36 months. 0.5 is my interest rate. My present value that I'm putting in is $1,000, and I'm going to calculate what my future value will be after 36 months. Notice when we're doing monthly, there are 3 segments that must all be the same. The N, the I over Y, and the payment. If any one of those, all 3 need to be the same. So if one's a month, the other 2 are also a month. If we make one annual, we make them all annual. Let's do this one on the calculator. Second, clear time value of money. Clear the number. Now, 3 years is how many months? 36. My interest rate is now 0.5% per month. I'm starting with, oh, one too many there, 1,000 negative. There's my present value. I have no payment. If I compute my future value, I have $1,196.68. Now let's try that for 5%. I'm sorry, 7% is what I said. Let's try that for 7%. Second, clear time value of money, clear my numbers. Now, we still have 3 years. How many months in 3 years? 36 in. 7% interest. What does that work out to per month? Let's take 7% divided by 12 equals 0.58333. Remember I mentioned earlier leaving the decimals? If I leave the decimals and I press I over Y right now, I've got all those decimals. So my I over Y is 0.5833 repeating. My present value is 1,000 negative. I still have a 0 payment. If I compute my future value, $1,232.93. There's the numbers we entered. 1%, you can see, added about $36 over the 36 months. Now, we just did that monthly. We could also do it semi-annually. Calculate the present value of $10,000 to be received in 10 years, discounted at 9%, compounded semi-annually. My interest rate is 9%. How much do I need today to have $10,000 in the future? If we're doing it semi-annually, how many periods are there each year? 2. So my interest rate, I take 9% divided by 2 to get my semi-annual interest rate. There are 2 periods in each year. 10 times 2 gives me 20 periods. So if I put that information into the calculator, there we have it, 20, and I put the essays in there just to remind us, it's 20 semi-annual periods. It's 4.5% interest per semi-annual period. My future value in this case is $10,000. What do I need to start with? Clear my time value of money. Erase the numbers. I now have 20 periods. 4.5. 4.5 is my interest rate. I have a 0 payment, and I want my future value to be $10,000. Compute my present value. You can see we need to start with $4,146.43. Now, we've done future values and future values, present and future. Let's try solving for an interest rate. You want to determine what interest rate you're receiving. So if Grandma gave you a savings bond that's worth $1,000, but you can't get that $1,000 for 20 years. She tells you she paid $214.55 for it. What is the interest rate that you're receiving on that $214.55? Now, we need to pay attention to the signs because we have cash inflow and outflow. We have 20 years. The present value is what we started with. Did Grandma pay that out, or was that a cash inflow? I believe that was an outflow. She paid it. So that'll be a negative $214.55. The $1,000 will come to us. That's a positive or a cash inflow. Let's plug these numbers into the computer, into the calculator. Remember, clear time value of money. Erase the numbers. 20N. We're going to compute the interest rate, so I'm not there yet. My present value, 214.55, is what we paid. Make that a negative number. My payment is 0. My future value is 1,000. Now I'll show you something here. If we're not sure we got the right numbers in, let's check our numbers before we compute. Second button right here is the recall. Let's recall my N. Yep, I had that right. Let's recall the present value. I missed that one, didn't I? 214.55 negative present value. Recall my payment. That's why I missed it, because I hit a wrong button. 0 is my payment. Recall my future value, and it's $1,000. We'll do that again. Now I should have the right numbers there. Recall percent. Recall N. Recall N was 20. I have 20 periods. Recall my present value. I have a negative $214.55. Recall my payment is 0. Recall my future value is 1,000. I can now compute my interest rate. Compute I over Y. And we come up with 7.999%. Or 8% per year is the interest rate that I would be receiving on that bond that Grandma bought for me. Now, why did I solve that using an annual interest rate? Why didn't I compound semi-annually or monthly? Because we assume annual compounding unless there's something to suggest otherwise. So if I tell you there's monthly payments, then we need to compound monthly because all of those need to be the same. There was nothing in this example to indicate that we should be doing anything other than annual, so we stick with annual. Let's do another interest rate. A $100 investment grows to $300 in 5 years. What is the annual rate of return? So what factors do I have there? Do I have a number of periods? Yes, 5. Do I have an interest rate? I don't see one. I have a $100 and a $300. Which one's present? Which one is future? If a $100 investment grows to $300, think about my timeline. Earlier, I start with 100, I end with 300. So 100 will be my present value, 300 will be my future value. The 100 is a cash outflow. I'll make that negative. The 300 will come back to me as a cash inflow. That'll be a positive number. So what is my interest rate? Clear time value of money. Erase my numbers. N is 5. 100 negative is my present value, a 0 payment, and 300 future value. I can now compute my interest rate. In order to go from $100 to $300 in 5 years, I would have to get 24.57% interest rate. Now, if we compound quarterly, what would change? Think, how many quarters are there in 5 years? 4 quarters in a year, that would be 20 quarters, right? Let's clear our time value of money information. Clear that number. So if I had 5 years and I'm now doing quarterly, I would have 20 quarters or periods. I'm still starting with $100 as a present value. I still have no payment, and I need a $300 future value. I can now solve for my interest rate. 5.65%. Now remember, N, I over Y, and the payment column are all in the same time frame. So that makes my interest rate a quarterly interest rate. So it's 5.65% per quarter. How would I make that an annual interest rate? I would take that number times 4, and my annual interest rate would work out to be 22.59%. Okay, we've done present values, we've done future values, we've solved for interest rates. Now we can solve for number of periods. How long will it take us? If $25,000 is invested at 12%, how long will it take to grow to $50,000? Now, remember that rule of 52 I talked about? I'm sorry, rule of 72. We can actually take 72 divided by the 12% equals 6 periods. Or we can do it on our calculator to make sure. Let's take a look at the calculator. Here we're looking at solving for the time. So if 25,000 is invested at 12%, how long will it take for it to grow to $50,000? We have 12% interest rate. We're starting with the $25,000, which would be a negative number because that's my cash outflow into the investment, and $50,000 will come back to me. Let's put that on the calculator. Clear our time value of money. We have a 12% interest rate. We have a $25,000 negative present value or cash inflow. We have a 0 payment, and my future value will be $50,000. To solve for my time frame is 6.1 or 6 periods. That's not right either. If we compounded that semi-annually, how long will it take to grow into $50,000? Now, if we do semi-annual, we need to figure out a semi-annual interest rate. 12 divided by 2 is 6% as a semi-annual interest rate. So we'll take a look. We have 6% semi-annually. We still have a present value of $25,000, and we have a future value of $50,000. Put those numbers into the calculator. Clear time value of money. Erase the numbers. 6% interest. $25,000 is a negative present value, and my future value is $50,000. I can put my 0 payment in there. And now I can compute in, let's see, let's recall in, clear, recall I over y was 6, recall present value is 25,000, recall payment was 0, recall future value is 50,000. Compute in is 11.89 semi-annual periods. So to get to the number of years, we would divide by 2, 5.95 years. So we've shortened the time frame just a little bit by compounding semi-annually. Because of the more frequent compounding, it's less. Now that you're familiar with using the financial calculator, you'll be able to use the calculator to calculate numerous problems. You're familiar with calculating present and future values. You'll be able to calculate interest rates, and you'll be able to calculate the number of periods needed to reach a certain amount of money. All of those problems are applications that you can use when putting together your personal financial plan.